Alright, you guys, so today we are starting 3-7, which is on parallel lines and transversals. You guys have seen parallel lines before, hopefully you kind of know what they are, but transversals you may not be as familiar with. Now these notes are going to look a little different. I already recorded this once and the file didn't work, so I'm not going to write all the notes again, but I'm going to go through it the same way. Your learning intention for the day is I am learning how to identify and prove relationships between angles formed by parallel lines and a transversal. Again, angle relationships. We've been working on these a lot. We know what we're doing with these. There's going to be some new relationships that you're going to see, but it's there, okay? So, success criteria, I can explain the concept of parallel lines and transversals and identify the different types of angles formed. I can use appropriate definitions, postulates, and theorems to support proofs. Again, you will have proofs on these later on. And I can apply the properties of parallel lines and transversals to find missing angle measures. That's the big one for today. Hopefully by the end of this you can do that third one. I can apply the properties of parallel lines and transversals to find the missing angle measures. All right. So, first part of this is on parallel lines. We've seen parallel lines before. We know what they are. So when we're looking through this, parallel lines are, for the sake of today, two lines, but two or more lines that never intersect. They never cross, they never touch, any of that. Okay? They use these arrows here to indicate the lines are parallel, and they use two vertical lines for the words parallel in symbolic notation. So line AB is parallel. Notice how those lines never intersect, they never touch, any of that. AB is parallel to CD. Then we have parallel planes. And if you need to pause the video, pause it. You're good. As we're going through this, it's going to be a little bit faster than it normally would be because it's already written. Okay? Parallel planes are the same thing. Two or more planes that never intersect. For the sake of today, mostly you're working with two, but there's going to be more. And symbolic notation, again, there's no fancy way of saying plane. Sometimes they draw a little like parallelogram, so it kind of looks like this. So like plane J is parallel to plane K. Sometimes they'll do that, but not very often. All right, so again, parallel lines, parallel planes, pretty much the same thing. And we had something that we talked about on a bell work a little while back. All right? Skew. Skew lines never cross, but they're also not on the same plane. So that's where this non-coplanar comes into play. Not coplanar, on the same plane. So if we're looking at this over here, we have 6 sides. We have 6 planes. You have the top and the bottom, you have the left and the right, and you have the front and the back. Non-coplanar. So TU, for example, is on the top plane and it's on the front plane. Any other line in this shape that is not front or top will be skew. So for example, WT. WT is part of the top and left. So any line that is not part of the top or left would be skew. I just said QP because I could. VU, again, top and right. So any line that's not part of top and right. I said SR because I wanted to. And then PQ is part of the bottom and the front. So again, any line that's not bottom or front would be skew. So I said SW because, again, I wanted to. All right. Example 1, name all segments parallel to AE. So AE was this left side over here. So any line that's parallel should also be going straight up and down. Well, there were 3. You had DH, you had CG, and BF. Right? Those are all parallel. give two examples of parallel planes. So just like this one up here, top or bottom, left or right, front and back. Those would all be examples of pairs of parallel. Top, bottom, left, right, front, back. I said EAD over here on the left side. So the one parallel to it should be over here on the right, FBC. Okay. Then I also said EFG, so EFG, the top, which would be parallel to ABC here at the bottom. And then name all segments skew to GH. So GH is up here on the top, so it's part of the top and it's part of the back. So any line that's not top or back, I highlighted the ones that were top or back, so that left us with BC and BF, AD and AE. Right? Again, I'm going through this fast. If you need to rewatch the video, go back through it, do what you need to do. Again, I'm showing you this. In the last video, I had you guys do this on your own, but this is just an example. You could have different ones. Okay? So name all segments parallel to JK. All right? JK was down here, the bottom part of this pentagon, five-sided figure. All right? None of these other sides are going to be parallel. None of the lines attaching the two pentagons are going to be parallel. So the only one that was parallel was down here, and that was OP. Name all segments parallel to NS. Well, NS was one of the lines that connected the two bases. So the lines that are parallel are also going to connect the bases. That's where I got MR, LQ, KP, JO, all that. Name a plane parallel to plane JKL. Well, JKL is the pentagon. Name the other pentagon. I don't care how you label it. I did OPQ. OPQ. And then name four segments skew to RQ. RQ is back here on this pentagon. So you couldn't pick any line that made the pentagon. You also couldn't pick any line that made up this kind of top rightish rectangle. You could use any of them from this pentagon. You can use any of the other lines that connect to the bases. So again, I had JO, KP, NS, and M. You can use any of the other lines though. All right? Again, if you need to go back, look at any of this, that's fine. If you have a question and they can't answer it in the room, please send me a message. All right? Next page. Now we get into our new stuff, okay? A transversal is any line that intersects two or more lines. So this line, for example, cuts through L and M. So that's my example. Line T intersects lines L and M. We're not going to deal with them too much in this way. You're going to see here in a little bit of how we normally work with it. But this little bit here, all right, I know this looks like a lot. I'm going to go through this as the best that I can. All right. Angles formed by a transversal. You can see, like up here, this one's a little bit easier to see. This is inside. So between these two lines is inside. Outside of them, well, that's the exterior. So we have exterior, like over here, exterior, exterior, interior is in here. All right. So corresponding angles. The way that I always remember it is you have one interior and one exterior, and they're on the same side. So I'll even put that in. I didn't underline that last time. Same side. So if we look over here, we need one on the outside, one on the inside, that are on the same side and in the same position. So, for example, this number 1 right here is in the top left. So I want to come down here and figure out which number is in the top left. Well, 1 and 5 are both top left. 2 and 6 are both top right. So that's corresponding. 3 and 7 are bottom right. 4 and 8 are bottom left. That's corresponding. All right. Alternate interior. Now you're going to have a left and a right side. Left and a right. Left and a right. And they're on alternate sides. They do not touch. No touchy. Alternate. Left and right. Interior on the inside, and they don't touch. So 4 and 6. 3 and 5. Okay. Alternate exterior. Same exact thing, except now they're on the outside. So 1 and 7. 2 and 8. All right, that's what we have over here. Same side interior. So now it's left and left, or right and right. Okay? 4 and 5. 3 and 6. 4 and 5, 3 and 6. Same side exterior. Again, same thing. Now it's on the outside. So 1 and 8. 2 and 7. This is really important to know. If you do nothing else in these notes, you need to write this down and understand the difference between corresponding alternate interior, alternate exterior, same side interior, same side exterior. You have to be able to see these. All right? We're going to play a little game called Name That Transversal. It's real fun. Okay? We're going to look at the different angles. So 1 and 12. 1 and 12. I don't care about this over here now. Okay, sorry, we're down here. Yeah, I'm covering that up. 1 and 12. You have outside and outside, so that tells me it's exterior. Are they on the same side of the line or opposite sides of the line? They're on opposite sides of the line. That tells me that it's an alternate exterior. Okay? How about 3 and 6? 3 and 6. Now that's over here. I'm just trying to cover it up as best I can, y'all. I know it's not working too well. 3 and 6. All right? Whatever. You guys can see it. I don't care. 3 and 6. We don't care about this bottom anymore. 3 and 6 are both on the inside. That's why we said interior. Are they on the same side of the line or on opposite sides of the line? They're on opposite sides, which makes it alternate. And then corresponding for this next one, 7 and 15. Now we're over here on the right-hand side. 7's on the top right, 15's on the top right. That's what makes it corresponding. And then 12 and 14, we're down here on the bottom. They're inside, same side. That's why we said same side interior. Right? What I want you guys to try to do is to fill in that bottom little portion. The 5 other corresponding, 5 other alternate interior, alternate exterior, same side interior, same side exterior. I want you to pause the video for a second, go through, and try to write 5 examples of each of those. You may not have gotten the same examples as I did, but you should have gotten some of the same examples, right? Because there are technically 8 of each type on these in this picture. Okay? So you have the one that was up here. Hopefully you guys, if you use one of these, that's fine. But in total, you should have 5 new examples of each of these. Again, check those out. See if you got some that are similar. Hopefully you did, because you kind of have to. There's only 8 options. Right? I don't really care about the non-examples. The non-examples are like going from something over here like the 1 and the 16. No lines, no similar lines go through either of these, so we don't care about those. Same thing here to here. Okay? So you could have said any of those. Let's go on to that next page. Again, if you need to pause the video to see that, go ahead, rewind it a little bit, you're good to go. Okay? All right. Next page of notes. This is what you're going to see more often from these notes or from these types of problems. When you have parallel lines and transversals. That's what you're going to see a lot more often. We're going to use those same terms we just learned. Corresponding, alternate interior, alternate exterior, same side interior, same side exterior. Okay? We're going to use the same stuff that we knew before. So here we have two parallel lines cut by a transversal. Corresponding angles are congruent. Again, top right is the same. Top left is the same. Bottom right is the same. Bottom left is the same. Okay. Alternate interior. So alternates on the inside are also congruent. Alternate exterior. Outside to outside, left to right are congruent. Are you seeing a pattern? Hopefully you are. Not. Consecutive, same side interior angles. So same side is going to equal 180 for both of them. Alternate interiors are congruent. Alternates are congruent. Same side is 180. And then you just have to remember correspondings are also congruent. All right. Something to remember, vertical angles are congruent. Linear pairs are supplementary. Again, things we've gone over plenty of times. Hopefully they're stuck in your head by now. All right. So we're going to look at this first example over here. Okay, we're just saying whether they're congruent or equal to 180 based on the reasoning. And this is the start of proofs for these. Okay, so we have 3 and 5. They are both inside on opposite sides of that line. That means they're congruent. 1 and 8. They are both outside on the same side. That means it's equal to 180. 2 and 6. They're both top right. Corresponding. Congruent. 1 and 7. Left and right. Both outside. Alternate exterior. 4 and 5. Both inside. Same side. 180. 3 and 7. Both bottom right, corresponding. 5 and 6 form a linear pair. That's why they said this equals 180. And then 2 and 4, they're across from each other. That's vertical. They are congruent. Okay. All right. This next example is actually going to give you angle measures. They give you that the measure of angle 12 is 121. It tells you that the measure of angle 6 is 75 degrees. They ask you to find everything else. So you have to go through each and every one of these angles to figure out the different pieces. All right? I'm just going to share a little bit of this. You weren't supposed to see that. All right. Measure of angle 1. This one over here. Do we have enough information for that right now? Well, 1 and 6 are created using vertical angles. Vertical angles are congruent. So 1 is 75. 2. We don't have enough information for number 2 yet. Why? Because we don't know what 5 is. And this other line is messing us up. So we got to skip 2 for right now. I know it says 46. That's the final answer. We'll get to that. 3. 3, we got 59. So how did we get that? Well, 3 and 11 are alternate exterior. Okay? So 3 and 11 have to be the same. Well, 11 is a linear pair with this angle 12, which is 121. So we can do 180 minus 121, which gives us 59. Alternate exteriors are congruent, so 59. That's how we can come back up here with 1, 2, and 3. That forms a straight line. That's 180 degrees. We know angle 1 is 75. We know angle 3 is 59. So that means angle 2 is going to be 180 minus 75, minus 59. That's how we get 46. All right. 59 for angle 4. How do we know that? Well, 3 and 4 are vertical angles. They are created by the same two lines. So 3 and 4 are the same. Right? Angle 5 is the same as angle 2 because of vertical angles. Angle 7 is the same as angle 12 because of vertical angles. 8 is the same as 11 because of vertical angles. 9. Well, we don't have 9 yet, do we? Oh, yeah, we can. Because we know 6 is 75 degrees. Angle 6 and angle 9, those are alternate interiors, so those are congruent. Angle 10, that forms a linear pair with angle 9, so 180 minus 75 is 105. We already said angle 11 was 59. Angle 13 is vertical to 10, so those are the same. And angle 14 is vertical to 9, so that's 75. I want you to try that last example on this page. Go and pause the video, and we'll get to it. Same side exteriors equal 180. So 180 minus angle 5, which is 94, gives us 86. Angle 3. Well, 1, 2, and 3 form a straight line. So we know angle 1 is 86. We know angle 2 is 41. If you subtract those from 180, you're going to get your 53. Angle 4, you can either say is corresponding to 1 or is a linear pair with 5. I don't care how you say that, but either way, you're going to get 86. Measure of angle 6. Well, 6 and 10 are, again, same side exteriors. These are going to add to 180. 7, again, linear pair. 6 and 7 have to add to 180. 8. 8's a tricky one. 8's tricky because, well, they've already cut this angle. So what we have to use is the fact that 2, 7, and 8 make a triangle. 2, 7, and 8 make a triangle. 2 is 41. 7 is 109. A triangle is made up of 180 degrees. So you subtract 180 minus 109 minus 41. So you get a total answer of 30. Then that final one, measure of angle 9. Well, we know 10. We know 8. That's a straight line. So 180 minus 109 minus 30 gives us 41. Wonderful job. Once again, I know I'm going through these a little bit fast. If you have to pause it, if you have to ask questions, ask each other questions. But at the end of the day, we are just looking at the relationships between these angles. We have one more page here, y'all. And on this page, all we're doing is looking at actual examples. Solving for the values of x and y. Again, I got to show you the work. There's no other way to do this. I'm not writing it again. We have two x's here. So we got to figure out what relationship do these two have. They're alternate interiors, which means they're congruent. So we are able to set 8x minus 31 equal to 6x plus 3. We go solve the equation. I know we can solve these equations. X is 17. We plug that back in. We get 105. We have a straight line here. So our 105 plus 5y plus 35 equals 180. You go ahead and solve that equation. You end up with y equals 8. I really hope that once we have this written as an equation, we can solve it. The hard part is this initial writing the equation. Okay? So I'm going to go through these. I'm going to let you guys work through it. All right? So, before I move this down, I want you guys to pause it, and I want you to try that second example on your own. How'd you guys do on that one? Did you get that x was equal to 14 and y was equal to 5? I hope you did. And you had to start out with the x's because there were two x's. One was on the inside, one was on the outside. They were in the same position. I'll call that top right and top right. So you have 9x minus 2 is equal to 5x plus 54. You go through, solve that, you get 14. You plug that back into 9x minus 2. 9 times 14 is 126. Minus 2 gives you 124. Linear pair here, so I'm going to subtract 124 from 180. That's where I got this 56 from. 180 minus 124. Set that equal to this 10y plus 6. Solved for 5. Solved for y. All right. Again, work through this. I want you to try that next problem on your own before you look at the next little bit. So pause the video. Angle or a corresponding, whichever way you wanted to go about that, and form a linear pair here. So again, linear pair, if this is 39, we know 180 minus 39 gives us the 141. So we were able to say 141 was equal to 8y minus 43 and solve. All right. Again, I'm not going through all this process. Hopefully you guys can do this part. I really hope you can do this part. One last problem. Pause the video. How'd you do? Did you get that x was equal to 9 and y was equal to 13? This one was a little tricky again, because at the end, I'm going to show you that. But we had our two x's. Those were, again, alternate exteriors. 15x minus 26 was equal to 12x plus 1. Went and solved, got x was equal to 9, plugged it back in for both of them. Vertical angle over here told us that this one on the inside was also 109. So then you had to use the fact that this was a triangle, just like that other one in the notes, and triangles are equal to 180. So we were able to say, get rid of that 109 and 28 just for this little bit to equal 43, and then you went ahead and solved. So, once again, a lot of work here. If you got through this in one day, I would be surprised. All right? I'm probably going to put in a thing to stop at a certain point because I want you guys to actually work on some other stuff. But whatever you get to today is what you got to. Ask questions if you have it. Good job today. I'll see you guys tomorrow.